Right, let's ask one of the younger members of the audience. How much of you is carbon? How much do you think? Do you know, it's about 1/6. Like a whole, both your arms. That much of you is carbon. And I'm going to talk about where that carbon's come from. Where do you think it comes from? Here's a clue. It's what you eat. You eat carbon in your food. Where does the food come from? Well, all the carbon that we eat as food has come through leaves, plants. And leaves do a magic job. They take carbon dioxide out of the atmosphere and they make it into food so that we can eat and stay alive. So the next question is, where does the carbon dioxide in the atmosphere come from? Now, we all know that we're making lots of it by burning things. And it's a problem because there's a little bit too much. In fact, most of the carbon dioxide in the atmosphere just goes round and round. When we eat the food, we oxidize it, we respire, and we breathe out carbon dioxide. It goes around and around. But the original carbon dioxide in the atmosphere had to come from somewhere, and this is where it comes from. Volcanoes. It comes out of the inside of the Earth. So the air we breathe has carbon dioxide in it that comes from volcanoes. So where do volcanoes come from? Well, the stuff in volcanoes, that hot lava and the gas that comes out, comes from inside the Earth, deep inside. So, next question, going back and back, where does the Earth come from? Well, we can get a clue by just looking at the Earth. It's going around the sun. Here we see a picture of the planets, all going around the sun in the same way. The sun's in the middle. And in the background there, all those little dots and this bright band across it, that's our galaxy. Our sun is one star in 100,000 million stars. Lots and lots of stars that make up the galaxy. And here we are, our Earth, going around the sun with carbon in it that comes out of volcanoes. So, where did the planets come from and the sun? Why are they going around like this? And this is what we think the sun and the planets were like when they started. 4,000, this is a big number, 4,567 million years ago. We know that quite precisely now. This is what the solar system, the sun and the planets look like. There aren't any planets. There's this big disk going round, big flat disk, shown red there, of dust and gas. And these little bodies here, they're small planets beginning to form. And those small planets became bigger planets, including our Earth. And they had with them some carbon. So, where did the sun and this disk around it, where did that come from? Well, we have to turn to astronomy now. And this is a picture of a big cloud of gas and dust in the galaxy. As well as all those 100,000 million stars, there are patches of gas and dust. And what's happening in these areas, this is called the Orion Nebula. What's happening here is that new stars are forming. What happens is that a huge volume of the dust and gas collapses under gravity and makes a new star, and it has a disk going around it where the planets are forming. And these have been observed now by astronomers. So we're really clear about how stars are formed. So our own sun formed this way about 4,567 million years ago. Okay, next question. Where does the dust in one of these big clouds come from which the stars are made? Where does that come from? Well, the dust and gas in our galaxy comes from things like this. This is a star that exploded about 1,000 years ago. And this cloud, this hot cloud of gas and dust is expanding fast. It was a supernova. And this is shedding its contents back into the galaxy, and new stars will be made out of it. So what happens inside a star? Where does the carbon in those stars come from? Well, it's actually made in the stars. This is our sun. In our sun, there is hydrogen being made into helium. But in bigger stars, the helium gets made into carbon. On the left, a small star, hydrogen burning to make helium. Here in this big one, in this zone, helium is burning to make carbon. And this process of helium becoming carbon inside big stars is amazing because it takes, on the left there, helium atoms. Two of them come together on the left to make a beryllium atom, and a beryllium atom adds to another helium to make a carbon atom. Now, what's amazing about this is that beryllium is really, really, really unstable. It lasts for 10 to the minus 17 seconds. It just goes pop, doesn't last at all. So how could this process happen? And this man, who's my hero, Fred Hoyle, he figured it out in the 1950s. It's called the triple alpha process. And he predicted, since we have carbon, it must have been made, this process must have happened, and he predicted that carbon and beryllium have an identical energetic state, allowing the reaction to happen in the short space of time. And just to finish off, our carbon comes, the carbon that makes us up, comes from stars that exploded before the solar system was made. That carbon went into the Earth, it came out as carbon dioxide, it got used by plants to make food that we eat. And this little object here is just 5 microns across. It's made of silicon carbide, and this came from a meteorite, a little bit of leftover space junk from when the solar system was formed. And this is a tiny grain of silicon carbide that came out of an exploding star. And we have it still to examine to this day. So thank you very much.